Okay, hello. Today we're going to review for the geometry interim assessment number 2. This will mimic the practice interim assessment that is available to you in Elluminate. The first question states that a regular pentagon is rotated about its center. What degree of rotation maps the pentagon onto itself? Well, there is a formula for regular polygons for the angle of rotation. And it is 360 degrees divided by the number of sides, or divided by n. And we're going to let n equal the number of sides. And in this case, n is 5 since it's a pentagon. So our angle of rotation is going to equal 360 divided by 5, which is 72 degrees. So our answer would be choice A. Okay, question number 2. Equilateral triangle ABC is shown below. Triangle ABC is then rotated 60 degrees clockwise about vertex C to produce triangle A prime, B prime, C prime. First of all, it talks about triangle ABC being equilateral. So knowing that we have equilateral triangle, we know every side is congruent to each other. And we also know that every angle is congruent to each other. So we call equilateral triangle also equiangular. And since the sum of the interior angles is 180 degrees, each interior angle is going to equal 180 divided by 3. So each interior angle, it will be 60 degrees. Knowing that, let's go ahead and select each statement that is true based on the definition of rotation. Vertex C and vertex C prime are located in the same place. Well, if we look a little bit closely to the question, it says triangle ABC is rotated 60 degrees clockwise about vertex C. Vertex C is our fixed point. Okay, that is a fixed point. So that is the center of the rotation. So vertex C is the center of rotation, and it is fixed. All right, so having said that, point C and its image C prime will be in the same position after the rotation. The next statement says the measure of angle B prime, C prime, A prime is 120 degrees, since 60 plus 60 equals 120. Well, remember, rotations are rigid transformations. Which means that it produces congruent figures. So corresponding angles should be congruent. Okay? So since angle BCA is 60 degrees, since each interior angle is 60 degrees, its image B prime, C prime, A prime would also be 60 degrees. degrees. So this would be incorrect. All right, the next statement, the measure of angle B prime is 60, and since the measure of angle B is 60, that is correct. Once again, rotations are rigid transformations. They preserve size, so an angle and its corresponding angle are congruent. The measure of angle BCB prime is 60 degrees, since 60 is the angle of rotation. So let's take a look at that for a minute. So the directions do say that B is being rotated 60 degrees clockwise. So let's say that B prime is located somewhere right here. Okay. The center of the rotation is C. So what I'm going to do is I'm going to, the vertex is C, and I'm going to create an angle whose vertex is C that has sides CB and CB prime. Every point on the pre-image is mapped onto the image through a rotation of 60 degrees. So angle BCB prime would also be 60 degrees. So that answer is correct as well. Question 3, triangle ABC is reflected over the line y equals 1. That is a line whose every point on that line has a y value of 1. So think about that. Plot a bunch of points that have the same y value of 1. The line would look like this. Okay, so that's the line y equals 1. Since point B is at 2, 2, we know that point B is 1 unit above the line y equals 1. So point B is 1 unit above the line y equals 1. Now, if we fold along the line of reflection, if we fold along the line y equals 1, then B will flip over the line y equals 1, the same distance below the line y equals 1. So B will now be, point B prime, will now be 1 unit below the line y equals 1. Now think about that. B prime's x-coordinate won't change. It won't be affected. So it was 2 and it'll stay 2. Now, if it was 1 unit above the line y equals 1 and it was at 2, okay? 1 unit below the line y equals 1 will be 0. So B prime will be located at 2, 0. Great. Okay, question 4. In triangle CDE, if it was reflected across the line y equals x, what would the coordinates of triangle CD prime E prime be? Okay, so what that is saying X equals Y and Y equals X. So the rule, okay, if we have the point X, Y, and we reflect it across the line X equals Y, all we're going to do is switch. Your X coordinate has to be your Y coordinate, and your new Y has to be your X coordinate. Okay, so if we apply that rule to each of the original points, point C is located at 1, -5. We would just merely switch the X and Y coordinates. So C prime would be -5, 1. If D is at 8, -2, if we switch the X and Y coordinates, D prime would be at -2, 8. And lastly, if E is at point 7, -6, its image E prime would be at -6, 7. And if you look at your answer choices, that would be answer choice D. Question 5. Segment AB is parallel to DC. So I'm going to mark them parallel using arrows. Segment AB is congruent to DC, so I'm going to use tick marks. What congruent statements can be proven using the givens in the figure above? So the triangles are stated to be congruent. These are called congruent statements. And when you make congruent statements, corresponding vertices must be named in the same order. So let's talk about the fact that AB is parallel to DC. And I am going to use a different color. If you remember, if I take the sides AB and the transversal AC and the side DC, we form this Z kind of pattern here. And if you take the alternate interior angles, if you remember, they're congruent. So angle BAC is congruent. Now let's match up corresponding vertices to angle. If we talk about angle B for a minute, well, angle B corresponds with angle D. And angle A corresponds with angle C. And angle A, so angle A corresponds with angle C. Okay, so let's take a look at this statement. We know that angle A, or BAC, is congruent to DCA. Okay, and we know that angle A is congruent to C. So if you notice, they are the second vertices named. Angle B corresponds to angle D. Angle C, which is DCA, corresponds to BAC. So if you look at the statements, angle C would be the correct. If you look at C corresponds to A corresponds to C, and B corresponds to D. Okay. If you look at the others, the vertices don't match. Question 6. If lines M and N are parallel in the illustration below, which of the following must be true about angle A and angle B? First of all, if we know they're parallel, we have special angle pairs that are either supplementary or congruent. And remember, when two parallel lines are cut by a transversal, or parallel lines are cut by a transversal, 8 angles are formed. I have these 4 angles here and these 4 angles here. And when I slide the left 4 onto the right 4, angle A and angle B will coincide. And another word for coincide are corresponding angles, or correspond. So angles A and B are corresponding angles, and corresponding angles are congruent. So the best choice is choice A. The measure of angle A equals the measure of angle B. And that's what the definition of congruent says, that if 2 angles are congruent, then they are equal in measure. All right, lines M and N are perpendicular. Which of the following statements are true regarding lines M and N? So let's draw lines M and N and make them appear to be perpendicular. All right, so let's go through our choices. It says, which of the following statements are true regarding lines M and N? Lines M and N form 4 right angles. Well, if they're perpendicular, the only way you'll know they're perpendicular if I use a square to indicate these lines intersect at right angles. And vertical angles are congruent, making this angle also 90 degrees. And we also have linear pairs, which are supplementary. So perpendicular lines form 4 right angles. Lines M and N intersect at a single point. This is true. They intersect right here at a single point. Lines M and N are equidistant from each other, the same distance from each other. We'll know they intersect, so that is incorrect. Lines M and N form 2 acute angles and 2 obtuse angles. No, we said they form 4 right angles. Okay, lines M and N do not have any points in common. Well, they do. They have this vertex point in common. Okay, so that is not true. Okay. Okay, question 8. In the graph below, figure 1 has been translated to form figure 2. The transformation can be described using the rule, the point xy maps onto question mark. What is the rule that describes this transformation? Use the on-screen keyboard to type the correct response. Okay, so what I would like to do is first find a pair of corresponding points. So I'm going to highlight this point here and its corresponding point on the image. And I might do that for a few pairs of points so I can see a pattern. And if I do that, this point right here would be 4, 6. And this point here would be 6, 1. All right. And if we were trying to figure out what type of transformation is occurring, I notice that 2 is the result after some sort of transformation that has occurred to figure 1. So I notice that figure 1 has mapped onto figure 2 by maybe moving down and to the right. Why do I know this? If you look at the y coordinates or x coordinates, we'll start with them. They move from 4 to 6, okay? And the y coordinates change from 6 to 1. The figure hasn't turned or flipped. It's simply slid. So just looking at that set of corresponding points, I can say that if we took the point 4, 6, okay, and use the rule 4 plus 2, I add 2 to my x coordinate, and then I subtract 5 from my y coordinate, I'll end up with the point 6, 1. Will that be true for another pair of corresponding points? So let me do the same thing for another pair of points and notice the change in coordinates. So now I'm going to pick these 2 points, here and here. Okay, the point in figure 1 is at 1, 6. The point in figure 2 is at 3, 1. Okay, so what kind of change has occurred? Well, again, I can say if we went from the point 1, 6 and we added 2 to our x coordinate and subtracted 5 from our y coordinate, we would end up with the image of 3, 1. So the rule then would be the same for all pairs of corresponding points. So the rule for any point x, y would be to shift every point 2 units to the right, and that affects the x coordinate, and shift every point down 5 units, and that affects the y coordinate. So that is the answer we would put right here. Okay. All right, it says in the diagram, in the diagram below, quadrilateral PQRS is a rectangle. Diagonal PR splits the rectangle to 2 triangles PQR and RSP. Based on the assumption that quadrilateral PQRS is a rectangle, determine which statement is true or false. Select true or false for each statement. So it states that triangle PQR and RSP are congruent because they satisfy the SSS triangle congruence criterion. Okay, opposite sides of a rectangle are equal. So I know PQ and S are congruent. I also know that PS is congruent to QR. And those are your shorter sides, so I know that PS corresponds with QR. I also know that PR is a side in both triangles, so segment PR is congruent to itself. So I have 3 pairs of corresponding sides congruent, so the triangles are congruent by side, side, side. The next statement says triangle PQR and RSP are congruent because they satisfy the side angle side congruence criterion. Okay, remember a rectangle is a parallelogram. Okay, and a parallelogram has 2 pairs of parallel sides. So I can think of PQ as being parallel to RS. And I know that alternate interior angles would be congruent. So I know that this angle, QPR, is congruent to angle SRP because alternate interior angles are congruent. I also know that segment PR is congruent to itself by the reflexive property. And I also know that segment SR is congruent to segment PQ. So the triangles would be congruent by side, angle, side. That's the included angle because that's the angle that is formed by the marked sides. So the second statement would be true. Next statement, triangles PQR and RSP are congruent because there is a rotation that carries one triangle onto the other. Well, let's talk about that choice. I know that triangle PQR will not be reflected or flip onto triangle PSR over diagonal PR because the corresponding vertices will not match up. So I know those two triangles are not congruent by a rigid transformation called a reflection. I know that the figures, one triangle has to turn to map onto the other. So I know it's not just merely a vertical slide or a vertical translation or horizontal translation. So can we turn one triangle so it turns onto the other? Well, yes, we can. So that is true. And last statement, triangle PQR and RSP are congruent because there is a translation that carries one triangle onto the other. No, because it's definitely turned. So that would not be a correct choice. Last question. A student wants to prove that the base angles of an isosceles triangle are congruent. The student draws the isosceles triangle ABC with base angles BC, B and C, as shown below. Okay. Now, we don't know that angles B and C are congruent. We're trying to prove that. It says point M is drawn as the midpoint of segment BC. Well, if point M is the midpoint, that point creates congruent segment to the left and to the right of point M. So segment BM would be congruent to segment CM. These two segments are congruent, okay? So let's go through our choices. It says segment AM is congruent to segment AM because of the symmetric property. Well, AM is congruent to itself, not by the symmetric property, but it would be by the reflexive property. So that is incorrect. It should say reflexive. So we know it's not choice A. The next statement says BM is congruent to CM because of definition of midpoint. Yes, midpoint is the point in the middle of segment CB, producing two congruent halves. Next statement, segment AB is congruent to AC because of the definition of the isosceles triangle. And yes, this is true because an isosceles triangle has two congruent sides. So yes, that is true. Next, it says triangle ABM is congruent to triangle ACM because of the side angle side triangle congruence criterion. Side angle side. Well, we don't know that the base angles are congruent. So that would be the included angle we would need to prove these triangles congruent by side angle side. Remember, side angle side, the angle is formed by the two pairs of congruent sides, so the congruent sides. So that would be angle C and B, and that's what we're trying to prove. So that's going to be a no. Now, why would the triangles be congruent? Okay. Again, anytime two triangles share a side, so segment AM is a side in both triangles. So segment AM is congruent to segment AM. That's a pair of sides. Segment AB is congruent to segment AC. That's another pair of sides. And segment BM is congruent to segment CM. That's another pair of congruent sides. So the triangles are congruent by side, side, side. So if we know the triangles are congruent by side, 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 Is angle B congruent to angle C? Yes. Remember the CP-CTC theorem? Corresponding parts of congruent triangles are congruent. We use this after we use a triangle congruence theorem to prove corresponding parts are congruent. So that would be a correct choice as well. All right, you should now be ready to take your interim assessment 2. Take care.